Hello and welcome to my channel. Walter here, and today I'm going to be taking you through the October-November 2024 Pure Maths 1 paper. That's 9709/12. So I hope you're going to learn a lot from what we're going to be discussing today. Let's get right into it. All right, so we are going to start with question number 1, and it says the diagram shows the curve with equation y is equal to a sine bx plus c for 0 to 2 pi. So these are values of x between 0 and 2 pi, where a, b, and c are positive constants. So in part A, state the values of a, b, and c. All right. Okay, so let's consider the function f of x to be the function sine x. So we are taking this graph, which is shown above, to be a transformation of the original function sine x. So it therefore means that a of f of bx plus c is the given function. That's a sine bx plus c. All right. So each one of these letters or constants, A, B, and C, represents some kind of a transformation. All right. Let's start from inside the bracket. Okay, let's start with B. All right. Now, before we can consider what type of transformation B represents, I'm going to draw on the same sketch, on the same diagram, the graph of y is equal to sine x, which would be the original graph from which this one has been produced. All right. So to make the sketch, it would be something like this. And it goes all the way up like this. So this is a rough sketch of the graph of y is equal to sine x. Now, if you look at it, okay, here, if we are considering B, this letter represents a stretch, okay? It's a stretch. And by the look of things, if we consider a comparable area, okay? For example, we can take the width within which is the first maximum, okay? So this is the maximum, and this width is comparable to this width of the original graph in which we have the first maximum, okay? I've just taken a similar measurement, okay, or similar or comparable width. And I think you can see that we can actually see that the graph of sine x has been shrunken, and that's by a half, by a factor of a half, okay? Because this width here is actually a pi, but here we have half pi. So the original graph has shrunken by a half. So we say that it's actually a stretch, and that's by a factor of a half. All right. So when we represent that in the function, we will be saying that b is equal to 1 over the factor. All right. So b is essentially 2. Let's go on to the next thing. All right. Removing this. Let's look at the letter A, the transformation represented by the letter A. Actually, A is right here, and A represents a stretch parallel to the y-axis. All right. So we can consider the range of our function, which in this case is 2 units long. Okay, so 2 units from -1 to 1. That's the range of the original function. But if you look at the range of the transformed function, you can see that it has actually been stretched, and it's now a range of 7 plus 1 of 8 units. So from 2 to 8 units, that's a stretch of factor 4. So since A represents a stretch parallel to the y-axis, it actually means that A, therefore, is actually 4, all right? Because from 2 to 8 units, that's a stretch, and that's by a factor 4. 4 times 2 is 8. Lastly, we're going to look at C, and C represents a translation, a vertical translation, all right? And we can pick a point, okay? Let's take this point here and a comparable point on the transformed graph, which is here. And we can actually see that the graph has gone up by 3 units. So that means that C is 3. All right, so I'll say here C is equal to 3. So this is how we find the values of A, B, and C. Let's move on to part B. Part B says, for these values of A, B, and C, determine the number of solutions in the interval 0 to 2 pi for each of the following equations. All right. So here, this is y. So y is equal to 7 minus x. So we can draw the graph of y is equal to 7 minus x. Here, when x is 0, y is 7. And when y is 0, x is also 7. All right. So we have to go on 7 and 7. 7 on the x-axis. Now, 7 on the x-axis would be something greater than 2 pi, maybe somewhere here. And another 7 is here. So if we are going to draw a line that goes across, we can see that within the range 0 to 2 pi, it intercepts 1, 2, 3, 4, 5 times, which means within the range, we have 5 solutions for this equation. So the answer is 5 solutions. Next, we're going to look for the number of solutions in y is equal to 2 pi of x minus 1. Okay, so where the function intercepts the line, y is equal to 2 pi of x minus 1. So for this one, I will say let x have the value, okay? I'm going to take values that are within range. I'll take a half pi. So if x has a value of a half pi, okay, a half pi, and we substitute that into here, it means we get 3.6 basically. So 3.6. So a half pi and 3.6, a half pi and 3.6, maybe somewhere around here. Let me use a green pen. Okay. Let's also take another value pi. When x has a value of pi, and we substitute that for x into here, we will get 13.5. So y is equal to 13.5. Okay, so 13.5 is way greater than 8. Okay, so it's pi and 13.5. So somewhere on top there, all right? So that if we draw a line to join the points, you can see that the line y is equal to 2 pi of x minus 1, okay, which is the one we have drawn. Y is equal to 2 pi of x minus 1, intercepts the graph at only one single point, which is this point here. So there's only one possible intersection between the two, which means that we only have one solution. So that's how we do it. Let's move on to number 2. The first term of an arithmetic progression is minus 20, and the common difference is 5. So on part A, find the sum of the first 20 terms of the progression. All right, so we've been given that A is minus 20 and D is equal to 5, and they want the sum to 20, which we find by half n, which is half of 20, of 2A plus n minus 1, which is 19, of D. So this is basically what we'll be having. Now, half of 20 is 10, and that's minus 40, and 19 times 5 is 95, all right? So it's 10 times minus 40 plus 95 is 55. So we get the answer here to be 550. Let's go on to part B. It is given that the sum of the first 2k terms is 10 times the sum of the first k terms. So find the value of k. So they are saying here the sum of the first 2k terms is 10 times the sum of the first k terms. Now for the sum of the first 2k terms, that's half of 2k of 2a. A is minus 20, remember, plus n minus 1 times d. D is 5. So remember, a is minus 20. D is equal to 5. We got that information from above. So we'll be having 5 of 2k minus 1 here. All right. And that's equal to 10 times half n, of which n is k. So it's half k of 2a and n minus 1d, which will be 5 of k minus 1. So this is what we're going to be using. All right. So here we get k of and minus 40, and minus 40 minus 5 is minus 45. So minus 45 plus 10k, and it's equal to 5k here, since 2 goes into this 5 times, and that's of minus 40. And actually it's minus 40, and multiplying here it's minus 5. So it's again minus 45 plus 5k. All right. And from here, I'm going to expand the brackets. So we have minus 45k plus 10k squared is equal to minus 225k, and that's plus 25k squared. So we're going to rearrange. So I'll take everything on the left side to the right. So I'll be having 0 is equal to 25k squared minus 10k squared is 15k squared. And minus 225k plus 45k is minus 180k. All right. So basically what we have is 0 is equal to 15k of k minus 12. All right. So it's either 15k equal to 0, where k comes out as 0, or k minus 12 equal to 0, where k comes out as 12. So the only value that k can have, k has to be something greater than 0. All right. From the way the question has been set out. Okay. So we get k to be 12. That's the answer. Okay. This one we reject. Let's move on. Now we're on number 3, and it says the curve y is equal to 2x squared minus 3x for points A and B with x coordinates 2 and 2 plus h respectively lie on the curve. So in part A, find and simplify an expression for the gradient of the chord AB in terms of h. All right. So this is what we have right on here. All right. So they say here that the x coordinates, okay, x has a value of 2. All right. And when x has a value of 2, we know that y will be equal to 2 of 2 squared minus 3. So that's basically 5. Okay. So it's equal to 5. So we know that the point A therefore has coordinates 2 and 5. And when x has a value of 2 plus h, y will be equal to 2 of 2 plus h squared minus 3. So that's 2 of 4 plus 4h plus h squared, if we expand, minus 3, which is 8 plus 8h plus 2h squared minus 3. So it's basically 5 plus 8h plus 2h squared. So we are therefore saying that B has coordinates 2 plus h and 2h squared plus 8h plus 5. All right. So for the gradient of AB, we'll say that it's changing y, which is 2h squared plus 8h plus 5 minus 5, okay, over the difference in x coordinates, 2 plus h minus 2. So essentially, we'll be having 2h squared plus 8h, which I want to factor out, okay? We can write that as 2h of h plus 4, right? And that's over the denominator will just be h. All right. So we'll be having here the h's cancel. So it's 2 of h plus 4, which can also be written 2h plus 8. So that's the answer here. Let's move on to part B. On part B, they say, explain how the gradient of the curve at the point A can be deduced from the answer to part A and state the value of this gradient. Okay, so they say we should explain how the gradient of the curve at the point A can be deduced from the answer to part A. All right. Okay, so as we approach the point A, okay, for the gradient, let me just write this down. For the gradient at A, okay, we can say that it is the same as the gradient at B, but as h approaches 0, okay? So remember we have got a chord AB, all right? Basically, we've got a curve, a point A somewhere and a point B somewhere, all right? And we know that A is a smaller value compared to B in terms of the x coordinates, all right? So as B gets closer and closer to A, it means that H is approaching 0 basically. So the gradient B as h approaches 0 would be like the limit as h approaches 0 of 2h plus 8. So if h approaches 0, it means we're just left with the constant 8. So therefore, the gradient will be 8. So that's essentially how we can do it for this particular question. Let's move on. On part B, they say, find the term independent of x in the expansion of each of the following. So on part A, we have x plus 3 over x squared to the power of 6. All right. So here we've got two terms. We've got an x term and a 3 over x squared. The powers of x start from 6, then 5, 4, 3, 2, 1, 0. The powers of 3 over x squared start from 0, then 1, 2, 3, 4, 5, 6. Now, to get a term independent of x, the powers of x and that of 3 over x squared have to be the same. And that can only happen when x has a power of 4, something like x power 4, and 3 over x squared has a power of 2. That's where the x power 4 on top will cancel with the x power 4 at the bottom we get here, and we get a term independent of x. But remember, this is a third term, all right? So this is like n choose 0, n choose 1. So the third term is n choose 2. So basically we have, in this case, 6 choose 2 of x power 4 of 3 over x squared to the power 2. That's the term independent of x. So 6 choose 2 is 15, and that's times 3 squared is 9, and the x power 4 and x power 4 will cancel out, all right? And 15 times 9 is 135. So that's the answer, all right? 135 is the answer. Let's move on to part B, where it says 4x cubed minus 5 of x plus 3 over x squared to the power 6. So basically, we're looking for the term independent of x. All right. So here, we know that if we do the expansion of this, we will have 4x cubed multiply the terms in the expansion of this. And at another point, we have minus 5 multiply terms in the second bracket. So to get a term independent of x, we should have 4x cubed multiply a term in the second bracket, which is a term in 1 over x cubed. And that's going to be minus 5 multiplying. And to get a term independent of x, that's when 5 multiplies a term independent of x in the second bracket. Okay, so here we'll get a term independent of x. Here we'll get a term independent of x. All right. So that's going to be 4x cubed. And for the term in 1 over x cubed in the expansion, okay, the power of x should be 3 degrees higher than the degree of 3 over x squared, basically. And that's going to happen, okay, for that to happen, it is when x has a power of 3 and 3 over x squared has a power of 3, such that we'll be having a term like 6 choose 3, and that's 6 choose 3 of x to the power of 3 and 3 over x squared to the power of 3. All right. So this term, if we say x cubed times 3 over x to the power 6, we'll get something that is like 3 over x to the power of 3, which is actually what we're looking for, a term in 1 over x cubed. All right. So I'll close the bracket and this minus 5 times the term independent of x, which we got above, which was 135. So 135. All right. So here we'll be having 4x cubed of 6 choose 3 is 20, and 20 times 3 cubed would be 540. All right, so we have 540, and that's over x cubed. All right, and that's minus 5 times 135 is 675. So here the x cubed will cancel, so that it's now a term independent of x. All right, 4 times 540 is 2160. So it's 2160 minus 675, and we are going to get the answer as 1485. So that's the answer we get here. Let's move on. Now we're on number 5. The function f is defined by f of x is equal to that for values of x that are less than a half. So state the value of f of minus 1, right? So f of minus 1 is 2 of minus 1 plus 1 over 2 of minus 1 minus 1. So that's essentially minus 2 plus 1, that's minus 1 over minus 2 minus 1, which is minus 3. So the answer comes out as a third. Let's go on to part 2. Part 2 says, the diagram shows the graph of y is equal to f of x. Sketch the graph of y is equal to f inverse of x on this diagram and show a relevant mirror line. Okay, so the graph of an inverse function is a reflection of the original graph in the line y is equal to x. And the line y is equal to x is the line that I'm attempting to draw now. This line here would be the line y is equal to x. So we have to reflect this graph, the original graph, in this line. All right. So if we are going to do it, we will be having something like, okay, reflecting this line segment, we should get something like this. And reflecting the other line segment would come to be like this. Okay, so this is more like the reflection that I'm getting right here, the line in green. That's y is equal to f inverse of x. Let's move on to the next part. Okay. Actually, that's part 3. It says find an expression for f inverse of x and state the domain of the function f inverse of x. All right. So the original function f of x, I'll say let y be equal to 2x plus 1. Let me use the right pen. Y be equal to 2x plus 1 over 2x minus 1. So x is equal to 2y plus 1 over 2y minus 1. We multiply both sides by 2y minus 1 and this side by 2y minus 1, and we get x of 2y minus 1 is equal to 2y plus 1. All right, so it's 2xy minus x is equal to 2y plus 1. All right, and that's going to be, do we have space? Yes, we do. Okay, if I use the proper pen, we have 2xy minus 2y is equal to x plus 1. Factor out y, so it's 2x minus 2 is equal to x plus 1. So we'll be having y being equal to x plus 1 over 2x minus 2. So therefore, the inverse function should be x plus 1 over 2x minus 2. The domain, okay, should be the range, okay? The domain of the function f inverse of x should be the range of the graph f of x. All right, so how do we know what the range of this function is? All right, so to get the range of this function, we can look at the behavior as x approaches negative infinity. Okay, as the graph continues to go to negative infinity, how does it behave? All right, so I'll say here for the domain of the original function, we can say as x approaches negative infinity, that is, as the graph continues to go more and more and more to the left, I'll take a very small value of x, say minus 1,000. The original function is y is equal to 2x plus 1 over 2x minus 1. So it's 2 of minus 1,000 plus 1 over 2 of minus 1,000 minus 1. And if we type that in, and we get 0.9999, so 0.999, which is very close to 1, okay, approximately equal to 1. So that's actually the limit, okay? That's the limit. So the range of the function is actually values of y that are less than 1, because that's the limit as we got here. So you have to know that the domain of the inverse function is comparable to the range of the function, which means that the domain of the inverse function should be x is less than 1. So that's what we're going to use here. X is less than 1 is the domain. So that's basically how we do it. Let's go on to the next one. It says the function g is defined by g of x is equal to 3x plus 2 for values of x that are elements of all real numbers. So on part B, solve the equation f of x equals to g of f of a quarter. So f of x is 2x plus 1 over 2x minus 1. And g of f of a quarter, okay, f of a quarter, okay, f of a quarter is 2 of a quarter plus 1 over 2 of a quarter minus 1. And this gives us on top 3 over 2 and at the bottom minus a half, which technically is minus 3. So when we then say g of, okay, let me move this down a little. And this here. So I'll say here, therefore, g of minus 3 should be equal to 3 of minus 3 plus 2. So that's like minus 9 plus 2, all right, which is minus 7, all right. So that's what we are equating here. So 2x plus 1 is equal to minus 7 of 2x minus 1. All right, so that's 2x plus 1 is equal to minus 14x plus 7. All right, so that's more like 16x is equal to 6. So x is 6 over 16, which is like 3 over 8. So this is the answer here. And that's how we do it. Let's move on to number 6. Now, on question number 6, it says the diagram shows a metal plate or A, B, C, D, E, F consisting of sectors of 2 circles, each with center O. The radii of sectors A or B and E or F are r centimeters, and the radius of sector C or D is 2r centimeters. Angle A or B is equal to angle E or F, and they are equal to theta radians, and angle C or D is 2 theta radians. it is given that the perimeter of the plate is 14 centimeters and the area of the plate is 10 square centimeters. So is 10 square centimeters. Given that r is greater than 3 over 2 and theta is less than 3 quarters, find the values of r and theta. All right. So let's start with the things they've given us. They told us that the perimeter of the plate is 14 centimeters. So that means that 14 is equal to, and then for the perimeter, we've got r, and we also have r, okay? So that is basically 2r. Then we have these two lengths, okay? This length and this length. And these lengths are going to be r and r again. Because you see how from this length should be r, okay? Because it's a radius of the sector OAB, so it's equal to r centimeters. So 2r minus r is r. So we have r here and we have r here again. So that's another 2r. So we have in total 4 r's. Okay, so we have 4r. Then we have the sectors, okay, the arcs. This one and this one are r thetas. So we have 2 r thetas. So just say 2 r theta. So it's plus 2 r theta. And the larger arc CD is actually r of 2 theta. Actually, it's 2r, the radius here, of 2 theta. So we have 2r of 2 theta. All right. So this is what we have in. All right. 14 is equal to 4r plus 6r theta. We can factor out r, or 2r rather, to get 2 plus 3 theta. Okay. So this is what we are having, and that's of 14. We can divide both sides by 2. So 7 is equal to r of 2 plus 3 theta. Okay. All right, let's just call this equation 1 for now. And let's now consider the fact that the area of the plate is 10 square centimeters. All right. So this we have done. Okay, so when it comes to area, which is 10 square centimeters, we have the areas of these two sectors, which we find by half r squared theta. So we have 2 half r squared thetas plus the bigger one is going to be half of 2r squared of 2 theta. Okay, so half of the radius, which is 2r squared, of the angle 2 theta here. All right, so we have canceling here r squared theta, 10 here, and here half, that's theta. So 4r squared theta. So 10 is actually 5r squared theta, and divide both sides by 5, we get 2 being equal to r squared theta. Okay, so that's what we have, and we're going to call that equation 2. All right, so we can now say from equation 2, theta is 2 over r squared. And if we substitute that into equation 1, we will be having 7 being equal to r of 2 plus 3 theta, which is 3 of 2, which is 6 over r squared, like this. All right. And we now have a good equation. 7 is equal to 2r plus 6 over r. And we multiply both sides by r. So we'll be having 7r is equal to 2r squared plus 6. So essentially we have 2r squared minus 7r plus 6 equal to 0. And that's 2r here and r. And we're going to have here 3 and 2. All right, minus and minus. And I think it should be good, right? So the possible values of r are going to be 3 over 2 or r is equal to 2, okay? However, from the information given, we are told that r has to be greater than 3 over 2. And here we had gotten r, one of the values, to be 3 over 2. So we're going to reject this. So the one we're going to use is r is 2. And we can also go back to equation 2, which was saying that 2 is r squared theta. So 2 is r squared theta. So therefore, 2 is equal to 2 squared theta, which means theta is equal to a half. So we're saying that here, theta is a half and r is equal to 2. Okay? Because that's actually, yeah, that should be right. And that's the answer here. Let's move on to the next question. Now we're on number 7. On number 7, it says, by expressing minus 2x squared plus 8x plus 11 in the form minus a of x minus b squared plus c, where a, b, and c are positive integers, find the coordinates of the vertex of the graph with the equation y is equal to minus 2x squared plus 8x plus 11. All right. So we have minus 2x squared plus 8x plus 11. This is minus 2 of x squared minus 4x plus 11. That's minus 2 of x minus 2 squared minus 2 squared plus 11. This is minus 2 of x minus 2 squared plus 8 plus 11, which is minus 2 of x minus 2 squared plus 19. So this is essentially what we get from completing the square. So therefore, the coordinates of the vertex should be, we take here 2 and outside 19. So that's how we answer it. Part B says the diagram shows part of the curve with the equation y is equal to minus 2x squared plus 8x plus 11 and the line y is equal to 8x plus 9. Find the area of the shaded region. All right, so to get the area of the shaded region, we need to know what the x values of the intercepts are here and here. So we need to know what alpha is and what beta is right here. Okay, so we will solve them simultaneously, all right? We'll equate them. Minus 2x squared plus 8x plus 11 is equal to 8x plus 9. So minus 2x squared plus 2 is equal to 0 if we move everything to one side, which means that x squared is equal to 1. So x is equal to plus or minus 1 if we solve this equation like I've just done. All right. Now, to get the area, we are going to integrate from minus 1 to 1. The area under the curve, the whole area under the curve, this curve. All right. So it means we're going to find the whole thing, the whole area here, which is minus 2x squared plus 8x plus 11 with respect to x. And we subtract from it the integral from minus 1 to 1 of, so we are subtracting now the area under the triangle here to get the shaded area. Okay, so we can do that by integration. where we're integrating 8x plus 9. All right, so 8x plus 9 with respect to x. That's for the line. Okay, so this should give us minus 2/3 of x cubed plus 4x squared plus 11x. Okay, and this is minus 1 to 1, and that's minus. Here we get 4x squared plus 9x, and that's from minus 1 to 1. Do we still have space? Yes, we do. We substitute 1, so we get minus 2/3 plus 4 plus 11 minus 2/3, and that's plus 4 minus 11. That's going to be minus. We come to this part. We'll be having 4 plus 9 minus 4, and that's 4 minus 9. Okay, so it becomes a plus because there's a minus on it, all right, like this. So this simplifies to minus 2/3 plus 4 plus 11, okay, and that's minus 2/3 minus 4 plus 11, all right, and that's minus. Here we say 4 minus 4 is 0, 9 plus 9 is 18, so that's minus 18 basically here, all right. So this is what we are having, okay. Simplifying this thing, we will say minus 2/3 is minus 4 over 3. Then 4 plus 1 is 15. 15 minus 4 is 11. 11 plus 11 is 22. And 22 minus 18 is 4. And what we have here simplifies to 8 over 3, which is the answer. All right, let's move on. Now we are on number 8. It says the equation of a circle is x squared plus y squared plus px plus 2y plus q equal to 0, where p and q are constants. So in part A, express the equation in the form x minus a squared plus y minus b squared equals to r squared, where a is to be given in terms of p and r squared is to be given in terms of p and q. All right. So we're saying here for this equation, if we rearrange, we'll be having x squared plus px plus y squared plus 2y. And that's equal to minus q if we move the minus q to the other side. And now completing the square for the first two, we get here x plus half p squared, and that's minus half p squared. And that's plus, completing the square on this one, we get y plus 1 squared minus 1 squared is equal to minus q. So what we will be having is x plus half p squared plus y plus 1 squared being equal to minus 1 crosses over, it becomes 1 minus q, which is already there. And this one also goes over and it becomes a quarter p squared. So this is what we'll be having. That's the answer here. Let's go on to the next part, which says the line with equation x plus 2y equals 10 is the tangent to the circle at the point 4, 3. Find the equation of the normal to the circle at the point A. All right, so we have a circle, the circle we're talking about, and they say that at a point A, there's a line which is a tangent to the graph circle at that point. All right. So like this. All right. And that's the line x plus 2y is equal to 10. So they say we should find the equation of the normal, okay, at that point. All right. So the gradient of the normal should be equal to, you see how we have x plus 2y is equal to 10. And x plus 2y equals to 10 can be written y is equal to minus of a half x and that's plus 5, right? Y is equal to minus a half x plus 5. So the gradient of the tangent is minus a half, which means the gradient of the normal should be minus 1 over minus half, which is 2. Okay, so that's the gradient of the normal. So for the equation of the normal, we would be saying that it's going to be y minus 3 is equal to 2 of x minus 4, which is y is equal to 2x minus 8 plus 3. So y is equal to 2x minus 5. So that's the answer to BI. Let's move on to part 2. They say we should find the value of P and Q. All right. So let's take this thing that we got, the little sketch, and let's place it down here. All right. So we have to consider some things, all right? First of all, let's consider the fact that the point A has coordinates 4, 3 as given, and the center, okay, the coordinates of the center, we can find them, will be minus a half p and minus 1, all right? So this is minus a half p minus 1. Let's call the center C, okay? And with this, we can actually find the gradient of AC. Okay, so the gradient of AC is equal to 3 minus 1 over 4 minus a half p. But this same gradient is the same gradient for the normal. Okay, the normal to the curve at the same point A, okay, is the same gradient. And the gradient of the normal, we had gotten that to be 2. So we're going to say this whole thing is equal to 2. So 4 over 4 plus half p is equal to 2. So 4 is equal to 2, or 4 plus half p, all right? So 4 is equal to 8 plus p, which means p is minus 4. So we have one of the answers. P is minus 4, all right? So that is something, all right? We can also consider the radius, okay? Let's talk about the radius. We know that the radius, we can find it, okay? That's basically AC. Okay, AC is the radius. Now, to find AC, we would say the square root of minus a half p minus 4 squared plus minus 1 minus 3 squared. This has to be equal to the radius, all right? Let me just move this a little. So this is equal to the radius, and the radius, okay, the radius squared is this, okay? 1 minus q plus a quarter p squared, okay? 1 minus q plus a quarter of p squared. But p is minus 4, mind you. We got that just now. So minus a half of minus 4 is 2. 2 minus 4 is minus 2. So this should be 4. Okay, and that's plus, this is 16. It's equal to 1 minus q plus a quarter of minus 4 squared. That's just going to be plus 4. All right. So this is what we have. So 20 is equal to 5 minus q. So q is minus 15. So that's the other answer. Okay, so we have p to be minus 4 and q to be minus 15. Let's move on. Now we're on number 9. On number 9, it says the equation of a curve is y is equal to half k squared x squared minus 2kx plus 2, and the equation of a line is y is equal to kx plus p, where k and p are constants with k ranging between 0 and 1. It is given that one of the points of intersection of the curve and the line has coordinates 5/2.5. Find the values of k and p and find the coordinates of the point of intersection. All right. So let's work on this particular type of question. All right. We are being told that the curve and the line intersect, which means we can say half k squared x squared minus 2kx plus 2 is equal to kx plus p. All right. Take everything to one side. So it's half k squared x squared minus 2kx minus kx. So it becomes minus 3kx. All right. So it's minus 3kx. And that's plus 2 minus p equal to 0. All right. So this is what we have, this equation here. But we've also been told that one of the points of intersection of the curve and the line has coordinates this, which would mean that x being equal to 5/2 should satisfy the equation above. So we can have half k squared of 5/2 squared minus 3k of 5/2 plus 2 minus p being equal to 0. All right. Now, this is 25/4 times a half. So that's 25/8 of k squared. And that's minus 15/2 of k. And that's plus 2 minus p being equal to 0. All right. Now, we can also make use of the fact that since y is equal to kx plus p, the y coordinate, which in this case is a half, also satisfies the equation. All right. So when y is equal to a half, x will be equal to 5/2. Therefore, a half is equal to kx, which is 5/2 of k, plus p. So we can actually express p in terms of k. So p is actually a half minus 5/2 of k. So from equation 1, if this is equation 2, we can substitute 2 into 1 to have 25/8 of k squared minus 15/2 of k plus 2 minus this, which is 2 minus a half plus 5/2 of k equal to 0. So technically we have 25/8k squared, and minus 15/2 plus 5/2 is minus 5. So it's minus 5k, and 2 minus a half is 3/2. So it's plus 3/2 equal to 0. Let's multiply everything by 8. So it's 25k squared minus 40k plus 12 equal to 0. And we can actually factorize this. 5k here, 5k here. Then minus 6 and minus 2. And it's factorized. So the possible values of k are 6/5, or k is 2/5. The question is saying we should find the values of k and the values of p. But we hear that k has to range between 0 and k. All right. So since k should range between 0 and 1, according to what they say, k should therefore be 2/5. All right. So if k is 2/5, we can use equation 2 to find the value of p. So we can say that p is equal to a half minus 5/2 of 2/5. That's like a half minus 1. So that's minus a half. So we are therefore saying, do we still have space? Yes. So we are therefore saying that k is equal to 2/5, and P is equal to minus a half. Now, the question also says, if you look at the question here, they say, and find the coordinates of the other point of intersection. All right. So to get the other point of intersection, we are going to take the combined equation, which is this one, all right? So when we combined the two, okay, we got this equation here. So I'm going to paste it down here. And remember, we got K to be 2/5, and we also got P to be minus of a half. So we are therefore saying we have a half of K squared, which is 2/5 squared. So essentially that's 4/25 of X squared minus 3K. So that's 3/2 of X, and that's plus 2 minus P. So that's like 2 plus a half, basically. All right. So this is what we have, and it's equal to 0. So simplifying this, we will get 2/25 of X squared minus 6/5 of X plus 5/2 equal to 0. Let's multiply all the terms by 50. All right. So all the terms by 50. And if we do, we'll be having here 4x squared minus here, we know 5 goes into here 10 times, so that's 60x, and that's going to be plus here 125 equal to 0. All right. So with what we have right now, we can actually factorize this quadratic. And if we factorize it, we can split the 4x squared into 2x and 2x, and have minus 25 and minus 5 here. All right. So we have factorized it, which therefore means that x has values 25/2, and x is equal to 5/2. All right. But this x value has already been given. Okay. We already know that 5/2 is one of the x values, but we're looking for the other set of coordinates, right? So we're now saying if x is equal to 25/2, what is y? All right. So we can go back to any one of the equations. Okay. If you look at this particular equation, that's y is equal to kx plus p. Okay. Y will be kx. K is 2/5. So 2/5 of x, which is 25/2. So it's kx plus p. P is minus half, so it's minus a half. So basically, this is 5 here, and the 2's cancel. So 5 minus a half is 9/2. So therefore, the coordinates of the other point which are required are 25/2 and 9/2. So that's the answer here to the other part of the question. Let's move on to part B. It says, it is given instead that the line and the curve do not intersect. Find the set of possible values of P. All right. Okay, so we are going to go to the combined equation. Okay, so we're going to come here. All right. So this is what we got. And I'm going to paste that here. All right. So since they do not intersect, it means that b squared minus 4ac should be less than 0. In this case, a is half k squared, b is minus 3k, and c is 2 minus p. So when we say b squared minus 4ac, we mean minus 3k squared minus 4 of half k squared, and c, which is 2 minus p, and it has to be less than 0. So that's 9k squared, and that's minus 2k squared of 2 minus p is less than 0. So that's 9k squared minus 4k squared, and that's going to be plus 2k squared p being less than 0. So that's 5k, 5k squared plus 2k squared p being less than 0. I'll factor out k squared. All right, so if we do, we'll be having 5 plus 2p being less than 0. All right, so here it's either k squared is less than 0, or 5 plus 2p is less than 0, where p comes out being less than minus 5 over 2. Right. So the question was saying, find the set of possible values of p. So we're going to make use of this. All right. This one here. That's the answer. Let's move on. Now we're on number 10. So number 10, it says a function f with domain x is greater than 0 is such that f prime of x is equal to 8 of 2x minus 3 to the power of a third minus 10x to the power of 2/3. It is given that the curve with equation y is equal to f of x passes through the point 1, 0. So on part A, find the equation of the normal to the curve at the point 1, 0. All right. So here we're looking for the equation of the normal to the curve at the point 1, 0. All right. So we are going to start by finding the gradient of tangent, and the gradient of the tangent, we substitute a 1 for x, right? So it will be 8 of, and if you substitute 1 here into the power third, well, we get minus 1 in here, and that's minus 10 of 1, okay? So basically that's minus 8 minus 10, which is minus 18, which means that the gradient of the normal is going to be minus 1 over minus 18. So that's just 1 over 18. So for the equation of the normal, we will say that's y minus 0 is equal to m, the gradient, 1 over 18 of x minus 1. So it's y is equal to 1 over 18 of x minus 1 over 18. So that's the answer here. Let's go on to part B, and it says find f of x. All right, so we have been given here that f prime of x, okay, is 8 of 2x minus 3 to the power of a third, and that's minus 10x to the power of 2/3. So now to get f of x, we will have to integrate the 8 of 2x minus 3 to the power of a third minus 10x to the power of 2/3 with respect to x. All right. So this will mean that f of x will be 8 of 2x minus 3. A third plus 1 is 4 over 3. So we'll be having 4 over 3, and that's over 2 of 4 over 3 at the bottom, and that's minus, all right, 10x to the power of 2/3 plus 1, that's 5 over 3, all right, and that's divided by 5 over 3, and that's going to be plus c. So f of x will come out as, all right, here 2 goes into 8 4 times, 4 times 3/4 would be 3. So it's 3 of 2x minus 3 to the power of 4 over 3 minus, then here 3/5 of 10, that's going to be 6. Okay, so 6x to the power of 5 over 3, and that's plus c. All right. So this is what we have in. All right. Now the question says that the graph y is equal to f of x passes through the point 1, 0. All right. So we're going to say here, since it passes through the point 1, 0, it therefore means that f of x, okay, which is y, we have a value of 0 here. So 0 is equal to 3 off, and we're substituting 1 for x. So here we will get, that will just be minus 1 to the power 4. So that's just 1. And here, substituting 1, we get 6 and plus c. So 3 minus 6 is minus 3. So c comes out as 3. So it therefore means that f of x, all right, f of x will be 3 of 2x minus 3 to the 4 over 3 minus 6x to the 5 over 3, and it's plus the constant c, which is 3, and that's how we do it right here. Let's go on to the next part, which says it is given that the equation f prime of x equal to 0 can be expressed in the form 125x squared minus 128x plus 102 equal to 0. Determine, making your reasoning clear, whether f is an increasing function, a decreasing function, or neither. All right, so here we are going to take 125 x squared minus 128 of x plus 192 being equal to 0, and we're going to complete the square. All right, we're going to complete the square. So, all right, so that's going to be 125 of x squared minus 128 over 125 of x plus 192 over 125, and that's equal to 0. All right. All right. So this is going to be 125 of, okay, now we want to complete the square, right? So that's of x minus, and half of 128 over 125 is 64 over 125, close bracket squared, and that's minus 64 over 125 squared plus 192 over 125 that is already there. All right. Okay, so I've just done the whole thing, and that's equal to 0. Okay, so that's going to be 125 of, okay, here I'll be having x minus 64 over 125 squared. And for this part, after multiplying by 125, we will get 19904 over 125. And if you look at this expression that we're getting, all right, if we just consider this thing that we completed the square to be f prime of x, so f prime of x equals to this, you can see that this thing here is always going to be greater than 0, okay? And that is for all values of x, because 125 is positive. This square is always positive for all values of x, and that's plus a positive. So this whole thing is always going to be positive for all values of x, basically. So we can use that to say that f is an increasing function because the gradient is always going to be positive. So that's how I can answer that question. And that does it for this paper.